Alright guys, welcome to this page of the notes, and now what we're going to do is we're going to begin to deal with that second objective or learning target, which is finding the slope of a function. This is still going to be a rate of change, but when it comes to finding the rate of change for the curve, the graph of a function, we don't call it rate of change anymore, we call it the slope, which will be abbreviated m. So you're going to recognize all of these equations, right? Rise over run. Actually, hold up, there's a typo right there. Let me fix that. It is delta y over delta x. That should be a y. That should be an x, right? So it's rise over run, delta y over delta x, y2 minus y1. That's the exact same equations that we saw for rate of change, but now because we're talking about the graph of a function, we're going to call it slope, and we just abbreviate that with a lowercase m. Now, a couple of things about slope. When you have your function, all you need to do is pick 2 points. You can pick any 2 points you want to, right? Remember we looked back on the first page of the notes. Doesn't matter what 2 points you pick. Doesn't even matter which point you label x1, y1, and which point you label x2, y2. As long as you do the math correctly, don't fat finger something on your calculator, you're going to get the same answer, which is awesome. That saves us a bunch of time and means there's one less thing we have to remember. But what you're going to be doing, right, is you're going to be finding the rise over the run. Now the rise is going to be on the on the vertical axis, or your y-axis. Let me draw these lines across. They have this point up here being y2, which means if I come all the way across to my y-axis, right over here, right there is y2. This point right here is y1, so if I come all the way across to my y-axis, right there is my y1. And when I'm asking you to find the change, I'm asking you for the difference between these two values, which is why we take y2 and subtract y1, and what's left is the difference between the two, right? Y2 is from 0 to y2, so it's this big distance. I subtract the little distance, and what's left over is the change in y. Now, for the run, the horizontal axis or the x-axis, well, this is x1, right? So I come all the way down, and right there I have x1. My x2 is this point over here, so I'm going to come all the way down to my horizontal axis. This is going to be my x2, and once again, in order to find the change, the difference between those two numbers, I'm going to take this entire distance from 0 to x2, whatever that distance is. I'm going to subtract this distance right here, and what's left over, well, that's the difference between them, the distance between x1 and x2. The change in x. So that's how this formula works. That's why it's y2 minus y1 over x2 minus x1, and that is always going to get you, when it's a function, the slope, which we abbreviate m. A couple of quick things to point out here. When there are lines, or we have lines that are not slanted, what if it's a line that's horizontal? Well, let me highlight something for you here real quick. A horizontal line will always have a slope of 0. Think about it for a second. If I come back up here to my graph, right, and I draw a horizontal line across here. Let me do that in green. Here is my horizontal line right here. Well, when it comes to this horizontal line, I'm going to pick 2 points. This point right here and this point right here. Let me do that for you. This point right here, and this point right here, right? So I've got this point and this point. Now, I still have an x2, right? My x2 is the same, and my x1 is the same, right? So that hasn't changed. There's a difference in x, which would be on the bottom, x2 minus x1, whatever that value is. The problem is when I have a horizontal line, y2 and y1. y2 and y1 are the exact same value. On the y-axis, it's the same thing. Any number minus itself, in this case it would be 2, so I'd have 2 minus 2, which is 0. Well, what I'm doing is I'm taking 0 divided by whatever that distance is. 0 divided by anything is 0, and that's why a horizontal line will always have a slope of 0. There is no run. It's a flat line. It's not rising any, right? There's no rise, and so it has a slope of 0. Let's keep going. What if you have a vertical line? Well, we'll go back to the graph in a second. We'll just let you know right here, this is going to have a slope that is undefined. Remember, we talked about this before. An undefined slope means that you are dividing by 0. Let's take a look at this. I can draw you guys a vertical line. Here you go. Let's put it right here. There's my vertical line. Vertical line right here. And I'm going to go ahead and pick 2 points in order to calculate my slope. Let's pick this point right here and this point right here. So there we go. I now have my 2 points. Well, my y2 is that guy right there. My y1 is this guy right here, and I absolutely can calculate the difference between those guys. That's going to be my rise, and it'll go right here for y2 and y1. The problem is when it comes to the run, when I calculate the difference in x, well, both of these points come down to the exact same x value, a positive 2. So I would wind up with 2 minus 2 in the bottom, and 2 minus 2 is 0. We are not allowed to divide by 0. Division by 0 is undefined. And as a result, anytime you have a vertical line, you are going to have a slope that is undefined. Let's go ahead and take a look at a couple more things here on this page just to finish it up. A positive slope, this is going to be a line that rises from left to right. Let me show you why. I'll real quick draw you a coordinate plane here. Let me throw a line on there. Say it's that guy right there. Now what's going to happen in order to calculate the slope is you're going to find the rise. There's the rise. Over the run, there's the run, right? Rise over run. Please notice that my rise is going up. That's positive. My run is heading, for you guys, right? Heading to the left, right? We're going in that direction. I'm sorry, heading to the right, which is going to be positive. And since slope is rise over run, rise over run, it is going to be a positive number divided by a positive number, which of course is going to come out to be a positive slope. So anytime your line is increasing from left to right, your rise will be positive, your run will be positive, and a positive number divided by a positive number. That's why we call it a positive slope. What about the other one? What if your line is falling from left to right? Well, let me go ahead and draw another coordinate plane for you. Let's drop a line on there. There's a good one. And let me put in my rise over run. Rise over run. Well, in this case, my rise is going up. My rise would be going up. But now my run is heading backwards, right? My run is heading in the negative direction. That makes it a negative number. And when I calculate rise over run, now I have a positive over a negative. Well, anytime you have a positive number divided by a negative number, you're of course going to get a negative number. So that's why a line headed in the decreasing direction from left to right is going to give you a negative slope. Guys, that takes care of everything on this page of the notes. Head on over to the next page and we'll try a few example problems. I'll meet you there.